This video is on how to find the exact values for sine, cosine, and tangent of 60 degrees, and how to find the exact values of sine, cosine, and tangent for 30 degrees. Okay, so first, if you type into the calculator something like sine of 60 degrees, you'll get this, 0.86602, etc. This here is not an exact value, because I think you can tell by looking at the number that there's another number past this 8. There's more numbers past that. So even if you went and wrote all these numbers for sine of 60, that is still not the exact value for sine of 60. So today, in our video, we're going to show how do you find the exact values for sine, cosine, and tangent of 60 degrees, sine, cosine, and tangent for 30 degrees. Okay, so to do that, we're first going to start off with an equilateral triangle. An equilateral triangle has all three sides are equal to each other. So that means this side here is equal to this side, is equal to this side. And that's what I sort of drew right here. All three of these sides are equal. All three of these sides are equal, which is what that symbol is representing. And so since we don't know how long each side is, I'm just going to put it as x. So each side is x length. A couple of properties of an equilateral triangle. In an equilateral triangle, all the sides are equal. We just said that. But also in an equilateral triangle, all the angles are equal. And because we know that the angles for a triangle will add up to 180, and because all the angles are equal to each other, 180 divided by 3 means that each of your angles is equal to 60. One more property about equilateral triangles, if you're just looking at the triangle, I think you can tell that this is a symmetrical shape. The left side and the right side look the same. Symmetrical. Okay, let's continue with this picture. So, if I have that shape right there, paste it here in our new. Okay, so we said that this triangle here is symmetrical. The left side and the right side look the same. What I'm going to do now is I'm going to cut the triangle in half. So starting at the very top, let's bring down a line. Try that again. Starting at the very top, let's bring down a line. We're going to cut the triangle exactly in half. Okay. Because we're starting at the top, we're cutting straight in half, and because the left side and the right side look the same, they're symmetrical. Therefore, that means that up here, this used to be 60 degrees, and when I cut it straight down the middle, the left side is now 30, and the right side is now 30 degrees. Okay? Looking at this bottom part right here, all the way from the left to the right side, that is length x. And now that I cut it in half, the left side is going to be 1/2 of x, and the right side will be 1/2 of x. Okay, let's clean this up a little bit. And here's the picture, a little cleaned up. So I cut the angle up top to 30 and 30, and I cut this length down here into 1/2 x and 1/2 x. All right, and for our purposes, we only actually need half of this triangle. So we're just going to take 1/2 of the triangle and erase it, and we'll just have that other half. So here we go, right there. All right. So, okay. So now we have our half of a triangle with one side, with one angle being 60, one angle is 30, which means the other angle is our 90-degree angle. Okay, so we know that our long side has length x. Our bottom side here is 1/2 x, that's the length. But we don't actually know how long this height is. In order to find this height, in order to find that length right there, we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. In the Pythagorean theorem, c is our hypotenuse. It's the long side, which is this one right here. It's our long side, or you can think of it as the side that is across from 90 degrees. So here's our 90 degrees, and all the way across from it is that hypotenuse. So that right there is my C. Okay. And I could choose, for the other two sides, one of them is going to be A, one of them is going to be B. It does not actually matter which one you choose is A and which one you choose is B. I'm going to choose this bottom one as B, and I'm going to choose the height to be A. So in our Pythagorean theorem, let's just plug in the values. C is equal to x. B is equal to 1/2 x. So I'm going to change the C to an x. I'm going to change the B to 1/2 x. And notice when I substitute it in, I put it in parentheses. That is, of course, the best way of doing it. So now let's simplify. In parentheses, x squared is just x times x. 1/2 x in parentheses squared just means 1/2 x multiply 1/2 x. All right, well, 1/2 times 1/2 is 1/4. And x times x is x squared. On the right side, x times x is just x squared. All right, and remember we're trying to solve for our value for A. So I'm trying to get A to be by itself here. So what I'm going to do first is I'm going to subtract 1/4 x squared from both sides. So a squared plus 1/4 x squared minus 1/4 x squared just becomes a squared. X squared minus 1/4 x squared. That's right here. Okay. So once again, to go from here to here, I just subtracted 1/4 x squared from both sides. Some of you may have been taught at one point that like you moved this to the other side, so the symbol changed to a negative. All right. And now I have here, reminder that when you have x squared and there's no number in front, that's a 1. So this right here is 1 x squared. And the number 1 is the same as 4 divided by 4. So I just changed the number 1 to 4 divided by 4. And now you can subtract these two fractions. So 4/4 x squared minus 1/4 x squared becomes 3/4 x squared. Okay, we're close to being finished. So here you have a squared is equal to this. To get rid of the a, you're going to do square root to both sides. So a square root of a squared just becomes a. And then you have square root of this, which is just shown here. Technically, it should say a is equal to the positive square root or the negative square root. Because a here in this problem represents a height, you can't really have a negative height if you're talking about a regular triangle like this. So I only kept the positive one here. So a is equal to square root of 3/4 x squared. All right. Well, square root of x squared is just x. Square root of 4 is 2. And you still are left with a 3 inside the square root. So long story short, a is equal to square root of 3/2 times x. So this a right here equals, or that height, equals square root of 3/2 times x. Okay, so let's continue. Now let's use this triangle right here to find sine, cosine, and tangent of 60 degrees and 30 degrees. So here's that same triangle from the previous slide. And I'm going to use that to find sine, cosine, tangent of 60 degrees, sine, cosine, tangent for 30 degrees. Okay, a quick reminder, sine, the quick reminder, SOHCAHTOA. SOHCAHTOA. And this is sort of separated into groups of 3. Your sine is equal to opposite divide hypotenuse. Cosine is equal to adjacent divide hypotenuse. And tangent equal to adjacent divide opposite. So your sine, let's put that there again, SOHCAHTOA. SOHCAHTOA. Cool. So once again, sine is opposite divide hypotenuse. So sine of 60 degrees is equal to the side that is opposite 60 degrees divided by hypotenuse. There's your SO. Cosine of 60 degrees is equal to the side that is adjacent to 60 degrees divided by the hypotenuse. And here we're talking about the lengths of these sides. And last one, tangent is equal to the length that is opposite of 60 degrees divided by the adjacent side of 60 degrees. Same thing over here, just substituting 30 degrees in instead. So let's do that. All right, so if we're talking about 60 degrees, right here is your 60 degrees. Opposite of it, so if I go as far away from the 60 degrees as I can get, that right there is the side that is opposite of it. So over here, this is the side that is opposite of the 60 degrees, which means that this other side is the adjacent one. So compared to the 60 degrees, this 1/2 x is adjacent, and that square root of 3/2 times x is the opposite side. So let's, this is opposite of 60 degrees, so everywhere here says opposite of 60 degrees. Let's change that for this. Here it says opposite of 60 degrees, so once again we'll change it to square root of 3 divided 2x. Compared to that 60 degrees, 1/2 x is adjacent to it. Adjacent just means next to. So everywhere I see a 1/2, everywhere I see adjacent side of 60 degrees, I'm going to change that for 1/2 of x. And finally, your hypotenuse is just, your hypotenuse is x, because that is your long side. All right, so that's looking at the sides compared to 60 degrees. Now let's look at it compared to your 30 degrees. Compared to your 30 degrees, the side that is opposite or furthest away is this one down here. So this side down here is the side that is opposite of 30 degrees, and then the side that is next to 30 degrees or adjacent to 30 degrees is this one. So anywhere I see the word adjacent to 30 degrees, that is equal to square root of 3/2 times x. So right here I see adjacent to 30 degrees. Let's change that for square root of 3/2x. I see that again here. The side that is opposite of 30 degrees is 1/2 of x. So everywhere I see opposite of 30 degrees, I shall change it to 1/2 x. Okay, my hypotenuse stays the same because hypotenuse is defined as the side that is the longest, or you can think of it as the side that is opposite of the 90 degree. So it's not, the word hypotenuse is not defined compared to the two small angles. It's defined compared to the whole triangle. So my hypotenuse is still x. And so I'll replace everywhere it says hypotenuse with an x. So there you go. There is your value for sine, cosine, and tangent of 60 degrees, right here. Sine, cosine, and tangent of 30 degrees. Now these look very, very messy, so we're going to simplify them. Here it is, just a little slightly less messy, and now we're going to simplify these. So here you have square root of 3/2x divided by x. So x divided by x just becomes a 1, or you can think of it as sort of, many of you think of it as this one and this one ends up canceling each other out. And so then you just have square root of 3/2. In the most technical, mathematically correct way, they're not actually canceling. These two x's, x divided x becomes a 1. And then 1 multiplied by square root of 3/2 just becomes square root of 3/2. All right, let's continue. So here we have 1/2 x divided by x. So once again, the x and the x will either cancel out, or if you want to think of it as they just become a 1. So then you're just left with 1/2 times 1, which is equal to 1/2. The same sort of thing is happening over here. This x and this x cancel out. This x and this x cancel out. So you're left with 1/2 here and 3/2 here. Let's do the tangents. They're a little bit more difficult. This x and this x will still cancel out. Now, there are two different ways you can think of this. If you have this fraction right here divided by this fraction, sure, you have that fraction divide that fraction. That is the same thing as taking this fraction here and multiplying by the reciprocal of the other one. So instead of 1 over 2, it'd be multiply 2 over 1. Okay, and so this right here is equal to this. And when you're multiplying, this 2 here will cancel out with this 2 here. And then you have square root of 3 over 1. Dividing by 1 doesn't change anything, so square root of 3 over 1 is just equal to square root of 3. Another way you could have thought of it is here. This divide 2 will cancel out with this divide 2. And so then you have square root of 3 over 1, which is equal to square root of 3. Let's do the same thing with this other tangent on the right. This x and this x will cancel out. If we think about it with this whole canceling here, this divided by 2 and this divided by 2 will cancel out. And so you're left with 1 over square root of 3. You're technically not supposed to have square roots on the bottom of fractions. So in order to get rid of this square root of 3 on the bottom of the fraction, I will multiply the top and the bottom by square root 3, and that gets this right here. So there you go. We've simplified our sine, cosine, and tangent for 60 degrees. We've simplified our sine, cosine, and tangent for 30 degrees. And here's what they equal. Two things I want to point out. One, notice that it didn't matter how long our sides were. So I started off by just saying this was x length, so some unknown length. So regardless of how long our hypotenuse is, if you have a 60, 30, 90 degree triangle, sine of 60 degrees will always equal square root of 3 over 2. If our hypotenuse was 16 long, this would have been 8 long. This would have been 4 square root 3 long, and when you still divide these two, you would still get square root 3 over 2. So sine of 60 is a constant. It's this number right here all the time. Same thing with cosine and tangent. And other thing I want to point out is if you sort of looked, you would have noticed that our sine of 60 degrees was equal to our cosine of 30 degrees. Vice versa, our cosine of 60 degrees was equal to our sine of 30 degrees. Interesting sort of property that they have.